In 2018, Facebook was hit by a massive data breach that exploited a vulnerability in the View As feature that allows Facebook users to identify what their profile looks like to other people. The breach exposed the access tokens of millions of users, allowing attackers to take over their account and steal sensitive information. The attack was made possible due to a combination of factors, including improper validation of user input and bug in the implementation of the View As feature. This allowed the attackers to execute a cross-site request forgery attack, which involves tricking a user into executing a malicious action on a website without their consent. Facebook has implemented measures to prevent such attacks from happening again, but the incident remains a reminder of the importance of constant vigilance to protecting web applications from security threats such as CSRF. So let's first understand what is CSRF token. When a user submits a form, the server generates a unique CSRF token and includes it in the form as a hidden field. The server also stores the token in a session variable on the server side. So when the server receives the form submission, it compares the value of the CSRF token in the form with the value stored in the session variable. If the value matches, the request is considered to be valid and is processed. If the value does not match, the request is rejected as potentially malicious. So through this way, the server is able to identify users. Now, what happened in cross-site request forgery attack? Basically, this attack happens when a malicious website, email, or other messages cause a user web browser to perform an unwanted action on a trusted site or on which the user is currently authenticated. Maybe it's not making much sense, but let's understand with an example. Have a look at this flowchart. What's happening here? Assume that the victim is logged into a website and that website has a feature that is update email. So when a user clicks on update email, a request is generated and the server accepts the request and then updates the email according to the data provided by the user. Now, how an attacker can change someone else's email? So basically, an attacker will host his own domain, which will consist of malicious JavaScript payload. And then the attacker will send that malicious link to the victim. And when the victim clicks on that link, a request will be automatically generated through that JavaScript code that will be sent to the trusted site. That site will think that the request was sent by the normal user and will accept it and update the email. But in reality, the request was sent by the attacker, and the normal user doesn't even know that their email is updated. And that's what I have showed in this flowchart. First, the attacker sends a malicious link to change email, then victim clicks on it, and then the victim is redirected to attacker's website. That website contains payload that sends a request from victim's behalf. Now the server accepts the request and changes the email. Now this is what exactly we are going to see in the practical demonstration. I'm going to use a lab from Podswigger, and it's a blogging site. There is a My Account feature through which we can log in using the credentials Weiner and Peter. Now I'm going to turn on my proxy and capture the request for updating my email. The new email value will be weiner00@normaluser.net. Okay. Now I'll send the request to repeater and click on send. Right now we are just testing how this update email functionality normally works. And in the response, we can see the email has been updated. Now we are going to test for something. Let's try to change the value of the CSRF token to test. And send the request. The server responded with 400 error, which makes sense because the token is wrong. Now let's try to change the HTTP method from post to get. Left click on the request side and choose change request method. Notice that the CSRF value is test. We will change the email value as well so we can confirm the change. Now click on send. The server responded with 200 OK. Let's see if the email value has changed or not. And yes, it did. So the server is not verifying the CSRF token when there is a different HTTP method in the request. It's only verifying the token when the HTTP method is post. Okay, this is interesting. Now, how an attacker can exploit this to change someone else's email? As we have already discussed, an attacker will host their own domain and use a malicious JavaScript code to send a request from victim's behalf. That's exactly what we are going to do here. The exploit server is the attacker server, and here I'm going to craft a request. Code is going to submit a different email while setting the HTTP method to GET. Since the server is not verifying the request in GET HTTP method, it will successfully change the email of another user. All we have to do is deliver this malicious link to the victim through email or social media, whatever. In this case, deliver exploit to victim is that link. Click on it and the lab is solved. This means that the victim clicked on it and the email was changed successfully. So this is how an attacker can exploit this vulnerability to perform actions on victim's behalf. Now, how you can avoid this kind of situation? Use a unique CSRF token for each form submitted by the user and validate it on the server side. If possible, limit the HTTP methods and verify the CSRF token in each request. Never include sensitive information such as session cookies in the GET request. Use same-site cookies to prevent cookies from being sent with cross-site requests. It is not recommended to use GET request when attempting to change the state of a system. Instead, use other HTTP methods such as post, put, or delete request, which are more appropriate for state-changing operations. Okay, so that's it for today. Thank you for watching, and I'll see you in the next one.